This one's going to do with something called continued fractions. And continued fractions are something I learned when I was in high school from my high school math teacher, Mr. Waterman. And the way you make continued fractions, I always remember from Mr. Waterman, there's 3 steps. It's been years since we talked about continued fractions, but do you remember what the 3 steps are?
I don't know.
The first one's split.
Split.
Split, sorry, can't spell split.
Oh.
Flip.
Flip.
And rat.
And rat. Good. Split, flip, and rat. Good job. That's how we make continued fractions. So first we need to separate, we split out the integer part and the non-integer part. And do you know what square root of 2 is as a number? It's between 2 integers.
1 and 2.
Yeah, so this is 1 plus the square root of 2 minus 1.
Yeah.
Okay, so we split it into its integer part and its non-integer part. What does the flip mean?
We have to get this on the bottom.
Okay, so this is 1 plus 1 over the square root of 2 minus 1. We flipped it.
Yep.
What does rat mean?
Rationalize the denominator.
Yeah. Have you seen that in your book, rationalizing the denominator?
No, not yet.
Okay, so we're going to do a quick little trick here. We're just going to multiply by the square root of 2 plus 1 over the square root of 2 plus 1. Because what is this fraction equal to? Square root of 2 plus 1 over the square root of 2 plus 1. It's 1. So we're just multiplying by 1, so no one's getting hurt, right?
Yeah.
Now what's 1 times the square root of 2 plus 1?
The square root of 2 plus 1.
Yeah. Now the square root of 2 minus 1 times the square root of 2 plus 1. That's a little more interesting.
That would be 2. It's not 2.
It's a little more harder multiplying. Do you know what this is?
It's 1.
Why?
Because it's a difference of squares. So it's 2 squared minus 1 squared.
Yeah. So there's a great little thing you learn in algebra. You'll learn this here, called the difference of squares. The difference of?
Squares.
Yeah, maybe we'll talk about it on the stairs.
Stairs.
So square root of 2 minus 1 times the square root of 2 plus 1 is 1. And then 1 times the square root of 2 plus 1 is that. So I get, this is 1 over the square root of 2 plus 1 over 1. But that's just 1 over the square root of 2 plus 1.
Yep.
Okay. So split, flip, and rat. So now we're back to split. Square root of 2 plus 1. What is going to be the 2 integers that's in between?
Well, that's going to be 2 and 3.
Yeah, so we're going to say 2 plus square root of 2 minus 1. Hey, we already saw that up here. What does the square root of 2 minus 1 turn into when I flip and rat it?
The square root of 2 plus 1.
Yeah, but on the bottom.
Which means you can keep doing this.
1 over the square root of 2 plus 1.
So.
Which becomes 1 plus 1 over 2 plus 1 over 2 plus 1 over 2. Does it ever stop?
Nope.
Nope.
It goes all the way down.
Infinite continued fraction.
So it never stops.
It's kind of an infinite descent proof.
It is kind of an infinite descent
More
proof.
literal.
It descends all the way down forever. So this is fascinating. So you make a continued fraction and the continued fraction never stops. And it turns out that when the continued fraction never stops, you get an irrational number.
Yeah.
But there's even just a little tiny bit more I'm going to show you here. Because there's a really easy way to get some great approximations to the square root of 2 here. So we do a neat little trick. 0, 1, 1, 0, and then we make our 1, 2, 2, 2, 2, 2. Another fun little thing from continued fractions. 0, 1, 1, 0. And we just multiply. 1 times 1 plus 0 is 1. 1 times 0 plus 1 is
1.
2 times 1 plus 1 is
3.
3. 2 times 1 plus 0 is
2.
2. 2 times 3 plus 1 is
7.
2 times 2 plus 1 is
5.
2 times 7 plus 3 is
17.
2 times 5 plus 2 is
12.
2 times 17 plus 7
is 36.
So,
No.
41?
41.
2 times
Thought there was
12
a
plus
two.
5.
That's
29.
29.
Okay, I'm going to stop here. These numbers all have really interesting properties. When I square the bottom and multiply it by 2, I get 2. Square it multiplied by 2, I get 8. Square multiplied by 2,
50.
50. Square multiplied by 2.
44. 28.
I didn't bring a calculator, so I don't know 29. We'll just stop there. But now when I square the top, I get 1, 9, 49, 289. What do you notice?
Approximations.
What do you notice about these?
Well,
These look closer and closer to. So they're all
like
one of their denominator away from 1. And it was less than 1, more than 1, less than 1, more than 1.
Yeah. So these fractions become very good approximations to the square root of 2. So 17/12 is a good approximation of the square root of 2. 41/29 is an even better one. But they're never ever going to be perfect. They're always off. In fact, they're always off by exactly 1 when you try to make the fraction.
Yep.
Pretty cool, huh?
Mhm.
All right, so there are 3 different ways of seeing that the square root of 2 is not
Rational.
Rational.
All right, good work tonight, guys.